Welcome, and thank you for joining us today. Can you start by telling us your name and a little bit about your experiment? My name is Dr. Clinton Joseph Davisser. My colleague is Lester Germer. My experiment is now famously known as, the Davisson-Germer Experiment. Now, this experiment did occur in the mid to late 1920s. It was kind of funny. We did all of this by accident. And I say that because our experiment unexpectedly provided the first direct evidence that electrons show wave-like properties. And this pretty much confirmed the idea of quantum mechanics, which is now known as wave-particle duality. So, Dr. Davisson, what exactly were you trying to do or trying to find in this experiment? See, now that's what was kind of funny. We were originally studying how electrons scatter off of different types of surface material. Now, in our experiment, we like to use nickel, and our goal was to understand the surface structure of, our goal was to determine surface structure and the different types of electron behavior, which, in all honesty, was nothing revolutionary at first. Now, the funny part, whenever we were doing this experiment, we had an accident in our lab, and we were putting it back together, and all of a sudden, it was just, we took notice, and just this weird diffraction pattern forming when the electrons had just kind of hit the nickel surface. And it kind of resembled, in a way, the way like an X-ray would, just waves being diffracted. So, in that moment, our entire focus just shifted. We realized that we were seeing direct evidence of electrons, kind of looking and being as waves. Now that you mentioned it, that is kind of funny. Now, with that said, where did you guys tend to, make or do, or, where did these experiments take place? So our entire experiment was carried out in Bell Telephone Laboratories, which is in New Jersey. At that time, it was a premier research center, and then it was moved into an AT&T, and then it was better known for Nokia. Sorry to cut you off right there. I know you said Nokia, which is another phone company, but moving to a different topic, what other significant events, was kind of happening around this time? It could be globally or, anything. As you know, I've already told you, our experiment kind of took place in the mid-1920s, and we finally had published it in 1927. So during this time, there was a whole lot going on. Globally, the world was recovering from World War I. Politically, it was tense, but it was still stable because that was right before the economic crash of 1929. Now, in the science world, quantum theory was evolving rapidly. There was that, and there was a French scientist. His name was Louis du Bois, which is how you kind of pronounce it in French. But he had the theory, and he proposed that particles like electrons might have the same behaviors like waves do, which, as you know, at the time, that was a purely mathematical theory. But, like I was saying, as you know, we confirmed his hypothesis, which was monumental. But my personal favorite memory is on December 2nd, 1927. The first Model A Ford had been sold. And if you want to take a guess, it was sold for $385. Hmm. So, Mr. Davison, who else was involved in this project? That's a great question. I'll go ahead and mention the Louis Du Bois guy. He, created the theory that we also confirmed. But I'd say pretty much it was Lester Germer and I. He was a very, very smart physicist. And to my knowledge, what I saw, he was a very meticulous experimentalist. We worked very closely on setups, measurements, and even the whole interpretation of the project. Very interesting. And if I might ask, what was your role in this entire experiment? I'm actually so happy you asked. So my role in this entire experiment, I was the lead investigator and the designer of the experiment, so to say. I helped supervise the apparatus construction along with analyzing early data. I also developed the framework to understand, basically just what we're seeing. Germer, he helped a lot. He was the day-to-day operator. He was a huge factor in ensuring the data was not only right but reliable. So that's kind of how our roles worked during this experiment. Okay. So overall, what impacts do you think that this experiment kind of made on the whole entire physics community? Do you think it helped? If I'm being honest with you, I think that our experiment was pretty monumental to the physics community. I think not only did our experiment become the cornerstone for the quantum mechanics, I think this because, we were the first people to provide the experimental verification for Du Bois' hypothesis. Our experiment, it showed the world that particles like electrons don't always act like particles. Under some certain conditions, they move like waves. They show the wave-like properties. I think our work helped the physics community overall because it laid the groundwork out for the development of electron microscopes, quantum theory, and honestly a new understanding of the dual nature of matter. And for that, our contributions, we were honored the Nobel Prize in Physics in 1937. I shared this with George Thomson, and George Thomson, if you don't know him, he independently demonstrated similar wave behavior using the electron diffraction through thin films. And so that's why I think so. Now that you mention that, I do. I think your experiment was pretty monumental to the physics community. With that said, we've only got time for one last question, sir. Looking back, what lessons do you think modern scientists can learn from your experiment? I think that's a good question to end on. I do. I really like that question. I think it's an excellent question. If I had to think about it, I'd say the biggest lesson that you can learn is to never ignore an unexpected result. And the reason I say that is because our discovery was born out of a lab accident that required us to completely rebuild our nickel target. If we had dismissed the strange diffraction patterns as an error, we could have missed out on one of the biggest moments in modern day physics. I think that I'd say the two best character traits a person in physics could have is curiosity and persistence. Because even when something seems like a mistake, it could lead to the greatest scientific breakthrough. But I agree. I do think it's getting very late, and I wish you the best. Thank you guys for listening.